Algebra half, short lesson on page 90, already done on page 91 there. It's just areas of triangles, a reminder of what we already know, but really important that we do know it, that we write this formula into our math notes, we use it regularly, we have it memorized, as I'd like not to have to use this on a cheat sheet in a test or quiz. You should really commit this to memory, that an area of a triangle equals 1/2 base times height. You could also show that as base times height divided by 2. Or the way that the book shows it on page 90, the word base times sign, word height, all over 2, divided by 2. Remember to divide by 2, even in triangles like this one. When we determine that the height is, say, 4, and we decide that this base, which is the bottom, the part that the triangle sits on the ground most flat, is 6. How do we solve? 6 times 4 is 24. Don't forget to divide by 2 to find that the area is 12, let's say, centimeters squared. You say, but there's 2 sides. This is still 180 degrees inside. It still requires you to divide by 2, and if you can't picture why, it's because if we found this base times this height, we would be finding all of this as if it were a rectangle. And can you already see how number 1 kind of matches with number 1 and number 2 matches with number 2? You have to kind of imagine this upside down and reversed, but we'd be counting in the end twice as much as we're supposed to if we didn't divide by 2. So we have to divide by 2 so that we get rid of all of this. Otherwise you're finding too much square centimeters or whatever you're measuring. So this is the height, or this is the height, or this is the height, jutting out from the 90-degree angle. A height will not be slanted like this. It's not on the ground. This is not a height. This is actually what's called a hypotenuse. We said this was the base. This can be called the height, or the book says, what's the other term? Maybe you can guess it now. Tude, the altitude. The perpendicular distance from the base extending from the base to the opposite vertex or corner. Any one of the 3 sides can be designated as the base. Thus, a triangle has a different height relative to each side. The altitude can be one of the sides of the triangle, fall inside the triangle, or fall even outside of the triangle. We don't really have one like that, but what if you don't have a 90-degree angle? And let's say this is not round, this is an obtuse triangle. Okay, if we have a triangle like that, there is a height, but it's none of these heights lines shown. It's actually outside the triangle. It's just the distance from the 90-degree angle, which in this case doesn't exist, to the top of the triangle. If you can't really tell from my terrible picture, take a look at letter C, both at the top of the lesson and under example 27.1. The height is not the slanted line, it is the imaginary height above. So in a triangle like this one, where this height is not a perfect 90 degrees, we figure what is 90 degrees, and that is the altitude or height. And we use that, and this is the base. And it was saying before that if you tip this on a different side, now this is the height and this is the base. Really, either of these can be height or base depending on how it's shown. Since we're just multiplying, which is commutative, it doesn't matter which side you put it on, it'll all come out right. Height, base, hypotenuse we're not doing yet. Divide by 2 finds the area. Write that formula in your notes. This is geometry, which is something that some of us scored lower on because we don't know our formulas and can't organize them as well in our minds. We need to really work on this weak point for ourselves. So please do B and C and show me the work and the answers on those. Thank you.